No, thanks for the opportunity to present today and talk about Yara Clean Ammonia and the ammonia industry and and the transition that we see towards clean ammonia, so meaning blue and green ammonia. As you mentioned, I represent Yara Clean Ammonia. That's the newly established segment in Yara. We've been in the ammonia industry for a long time, but February this year we merged our portfolio of projects on the ammonia side with our existing ammonia trade and shipping business into one separate segment on a global scale. And when it comes to energy and clean energy, this is in many ways going back to our roots. We were founded in 1905 based on an invention by a gentleman called Birkeland and an entrepreneur called Sam Eide, who together invented a method of capturing nitrogen from the air, Birkeland-Eide method. And the whole premise for that was Norwegian hydropower and clean electricity, although of course at the time nobody thought about it as clean, or that distinction didn't exist, obviously. And in many ways what we do now is pretty much going back to our roots on this. We started using electrolyzers for ammonia production in the 1920s, so over 100 years ago, and that actually lasted quite a while. And it wasn't until the 60s and 70s that we started to replace our electrolyzers with steam methane reformer and using natural gas in the production of hydrogen and then ammonia, which is how our ammonia plants are set up. And then actually our last electrolysis plant was shut down in the 90s, as late as that. So in many ways, going back to green ammonia now is to some extent going back to our history. 2 words on Yara as a company. We of course have a large presence in Brazil on the fertilizer side, and where we are moving our company now is basically 2 legs. One being what we call our core towards food solution, which is the extension of our crop nutrition and fertilizer business, which is of course a very important part of what we do in Brazil. We have roughly a 25% market share of the Brazilian fertilizer market and one of the biggest distributors there. Then the second leg, which is based on our ammonia business, is what we call enabling the hydrogen economy. And it's some maybe a little known fact, but of course, being the largest ammonia producer in the world, we are also one of the largest hydrogen producers in the world. So in our ammonia plants, they are basically a hydrogen plant plus a synthesis loop, and ammonia is in that sense a very efficient carrier of hydrogen. When we look at the hydrogen economy and the ammonia market as such, you can read day and night reports on how much the market will grow and into which applications and so on. And there are a significant set of reports, and of course I think the only solid comment around this topic is that there is of course a high degree of uncertainty. Probably not so much on the volumes that will eventually be there, but certainly on the timing of it. And basically, when it comes to ammonia as a clean fuel or as a clean application of hydrogen, there are basically 2 components, as was mentioned earlier, which is blue, which is then ammonia produced in the traditional way with CCS, carbon storage and capture. And there is green ammonia, which is basically replacing the steam methane reforming using electrolyzers and then renewable energy to produce the hydrogen instead. And the applications are quite wide. So we heard about the using ammonia as a clean shipping fuel, which is one. But there's also a potential in power production, or using ammonia as a fuel for power production in countries with either very expensive or scarce renewable opportunities. And obviously today most of the ammonia goes into fertilizer, so there's also a significant potential there to decarbonize a large portion of agriculture through blue and green ammonia. So in terms of the timing aspect, the potential is significant, but of course timing will depend heavily on development of technology and new projects. And why ammonia and in the kind of the hydrogen debate? I think most people have heard about hydrogen and how hydrogen is an important part of, for instance, the European Union's Green Deal as a fuel source where, for instance, batteries will not be sufficient. Hydrogen can store 1.5 times the amount of energy per volume unit as hydrogen can. And also in terms of shipping it, compressing it, ammonia has some very attractive attributes compared to hydrogen. The fact that it needs to be cooled down to -33 as opposed to -253 as one example. But maybe more importantly, there are a lot of applications for ammonia today that already exist, and the fertilizer industry being one. But also the shipping industry, obviously not consuming any ammonia today, but where there's significant development on the engine side to prepare that. And I think, as was mentioned in the previous presentation as well, this isn't something that will happen overnight. There will be some pilots, some companies leading the way, and obviously there's a technology component that needs to be in place, both on the engine side, but also in terms of fueling infrastructure and so on. But we will see the first prototypes quite soon, and also the first commercially viable engines in 2 to 3 years as such. But in terms of scaling the market, that's of course something that will be longer into the future, and also will require quite significant increase of production capacity. But I think the interesting part is, of course, that in terms, if you measure it against what's available of supply today, and also what's realistic in terms of adding supply, both on green, gray, blue, but also what's available on gray ammonia, I think the issue here, or the challenge for the development of ammonia, for instance, as a shipping fuel, will not be demand, it will be supply. Of that, we're relatively comfortable. Looking at targets, and that was talked about earlier as well, I think one thing that we like to point out is if, for instance, look at the European Green Deal and their targets for installed capacity of hydrogen, they've set some pretty ambitious targets with 6 gigawatts installed in 2025 and 40 gigawatts in 2030 from basically nothing today. And hydrogen and electrolysis production with current technologies, both in terms of the capex needed to develop it, but also the efficiency of the electrolyzer, is still at a level where hydrogen is not competitive with other sources, whether that in the fertilizer industry or as against shipping fuels or other applications. There is, however, a significant improvement expected, and if you compare with other renewable sources such as solar or onshore offshore wind, we of course there is so a significant learning curve and decrease in unit cost over time. And I think the other aspect which is interesting is, of course, that all the projections laid out on those technologies turn out to be wrong, in the sense that it went much faster than what anybody would assume. But there's no doubt that it will take time to develop, particularly green hydrogen and then green ammonia to a level where it gets more in line and competitive on the cost basis. And what is needed is, of course, scale. You will need scale in terms of large scale developments to make that learning curve and make the industry develop into and bringing costs down to a level. Sort of the aim, or I would say, is dangerous to use the word consensus on something that where assumptions are so uncertain, but there's sort of a convergence towards $2 per kilo hydrogen produced in the European Union by 2030, which would be a significant improvement from where we are today. I think the industry, the electrolyzer industry as such, feels confident, obviously, that that's a target that's achievable. But that's also the level we will need to get to for this to be commercially viable over time. But also, in order to achieve the targets that the EU has set, and although they are pretty ambitious, there is no doubt that you will need to use existing applications of hydrogen, such as ammonia, to make this happen. Because what is often forgotten and not talked widely about is that when it comes to hydrogen, if the hydrogen is to be used in a refinery next door to where it's produced, that is one thing. But there is no infrastructure today globally anywhere to either store, handle, or ship hydrogen from where it's produced to where it's supposed to be consumed. And for instance, there is of course the possibility of producing it next to the consumption. The good thing about electrolysis is that it's both scalable and you can produce it at a relatively low with a relatively low volume. The challenge, of course, in the sense that there's no way of shipping it around, is of course that your reliability of supply is relatively problematic if something were to happen to your production system. And that's the difference between hydrogen and ammonia, is that for ammonia, there is a global infrastructure to distribute this today. And if you look to existing ammonia production plants, it is only the front end of the plant, the SMR, or steam methane reforming, that needs to be exchanged with the electrolyzer. That, of course, is a significant undertaking in itself. But once that is done, basically the rest of the value chain is basically there, and no other changes are required in terms of handling and shipping and distributing. That is 100% true for fertilizer. Of course, when it comes into other applications such as ammonia as a shipping fuel, of course, there is a last mile element there on bunkering, which is significant, and of course you have the whole engine part as well. But ammonia as an application is a hydrogen application where the infrastructure exists today. Very briefly on Yara and our position is, our main attribute to this market is of course our production capacity. We are the biggest producer of ammonia globally today, and also the biggest trader of ammonia, trading roughly 20% of the world's shipped ammonia.
Magnus, 2 minutes.
Yeah, and we run our own ships, 11 vessels, of which we own 5, and also significant storage capacity worldwide. And for us, of course, the production element is important, that we have a flexible system of multiple sources to serve the market. But also this puts us in a position to start serving the market in small bits with the small pilots that we have, but also the first vessels that eventually will come along. And that's the role that we see for us in this market, is to be an integrator on the distribution and production side. But obviously this is something that requires partnership, but also the consumers of existing but future ammonia applications. And just finally, one word on our first major project. So we are running a couple of smaller pilots, both on blue and green ammonia today, but our major project now is conversion of our 500,000 ton ammonia plant at Herøya in Norway, where, by the way, quite a lot of fertilizer shipped for Brazil is produced. And we have their joint project with Aker and Statkraft to transform that plant and transform the SMR into an electrolyzer and produce green hydrogen and green ammonia. That will remove 800,000 tons of CO2 from one of the largest single emitters in Norway. And this is, of course, one of hopefully many projects going forward. So to conclude, we think that ammonia has a very bright future as in the green transition. We do think that it will be a journey that will take many years, but I think the journey starts now. Thanks for the opportunity to present.